Hi there, so this is Nate Moore, and I'm going to try to teach you guys working with derivatives and particle motion. So I'm going to use a couple of these word problems to kind of explain how to kind of go about using derivatives with particle motion. For instance, our first question is, a billiard ball is hit and travels in a straight line. If x centimeters is the distance for the ball to its initial position at t seconds, then x of t equals 5t squared minus 4t. If the ball hits a cushion that is 12 cm from the initial position, at what velocity does the cushion hit? Now, to do this, what we're going to have to do first is let's write out our equation, which is x of t, which is equal to 5t squared minus 4t. Now, to get our velocity, we'd have to take the derivative of this. So x of prime of t is going to be equal to 10t minus 4. So now we're going to try to find this cushion that is 12 cm from its initial position. To do that, we have to set our original equation equal to that 12 because that was the initial position. So then we're going to try to solve for t. To do that, we just kind of move 12 over, so we have 5t squared minus 4t minus 12 equals to 0. Then we could just factor, trying to find two values that multiply to, or add to 4 that multiply to negative 60. And those two values would be 6 and negative 10. 6 and negative 10. So then we'd have something like t plus 6, t minus 10 is equal to 0. But I like to use the slide and divide method, so I'm going to divide both of these by 5. So then our values here would be x is equal to negative 6 over 5. Sorry, not x. This would actually be t because we're talking about time. And t is equal to positive 2. Now, if we're talking about time, we are not going to look at negative values. So unfortunately, we're not using this answer. We're going to figure out that our time was after 2 seconds is when we hit this cushion. Now, what are we doing with this time part? Well, we're going to use that in the velocity equation then. So we're going to take 10, not 12. We're going to take 10 instead of t, we're going to plug in our 2 there, minus 4. So here's our time value. If we plug that in, well, 10 times 2 is 20, minus 4 is equal to 16, and that is centimeters per second. So that's the first question. Let's look at this in another context. So example 2, if a particle moves along a line according to this equation of s of t equals t to the power of 5 minus 5t to the power of 4 for all real numbers t, then how many times does the particle reverse its direction? What we're trying to figure out is essentially along a line where and how many times it kind of goes above and below the x-axis. So to start this, what we can do is that we're going to take the derivative of this function to find out the velocity. So minus 5t to the power of 4. So let's look at s prime of t, which would be 5t to the power of 4 minus 20t to the power 3. Okay, so remember, we're looking at where it equals 0, these points where it crosses the x-axis, so we're going to set the derivative then equal to 0. So we'll have 5t to the power 4 minus 20t to the power 3 equals to 0. Then I'm looking for things I can factor out here. Well, they both have a 5 that I could factor out, so I could factor out 5, and the greatest common factor of powers is t to the power 3, so we'll factor that out. What are we left with? T to the power 1, or just t, minus 4 is equal to 0. Well, now I'm trying to find values I can plug in for 0 here. So obviously, t will be equal to 0 here, and t will be equal to 4 here. So these would be our two values on the x-axis that we're trying to look at. So we know that this one would be 0, this one would be 4. Now we're trying to figure out if, like, if we're looking at some kind of curve here, is it going to be positive or negative at this point, positive or negative at this point, or positive or negative here? So what do we do to do that? Well, we have to try to find some value smaller than 0. Let's use 1. So instead of s prime of t, we're going to try s prime of 1. And if we plug 1 into this, instead of 5t, we'll have 1 to the power 4 minus 21 to the power 3, and that would give us 25. Well, we don't care so much about the 25. We care more that this is positive. So if it's positive, then we know that the line will be coming in kind of like this. So let's try another one, something in between 0 and 4, something like, oh, sorry. Yeah, that was 1. Oh, I sorry, I was supposed to use -1. Sorry, -1. This was -1 equals 25. My mistake. So let's do s prime of 1 this time. This time I'll get it right. Minus 20 to the power 21 to the power 3. Here we get -15. Because we get -15 in between here, this would be negative. And then we could try one more time if we do let's say S5, because that's greater than 4 on this side. If I already plugged it in, you would have gotten a value like 625, which is also positive. So we would have gotten something like this. So it only changes direction one time. So how many times does the particle reverse its direction? Changes one time, right? Because we go from down to up. So we're basically going down, then up. So it only changes direction one time. Last one is example 3. The position meter of a particle moving on x-axis is given by x of t equals 2t to the power 3 minus 2t plus 1 at all times of t where t is greater than 0. Find the acceleration where the velocity is 4 meters a second. To do this, once again, let's write out our equation. X of t is equal to 2t to the power 3 minus 2t plus 1. To find our velocity, we have to take the derivative. So let's take the derivative of this, which would obviously be, that will be 6t minus 2. So this is our velocity. So we can also think about this as our v of t. To find our acceleration, we have to take the second derivative. So it's like saying x prime prime, which of t, which is equal to v prime of t, which would actually be equal to our a of t, which is our acceleration. So if we take the second derivative of this, it would just be, oh, I forgot, power 2. My mistake. So then this would just be 12t. So what are we trying to do? Well, we're trying to find out what our velocity is 4 meters a second. So to do that, we're going to take our velocity one, which is this equation, and we're going to make it equal to 4. So we have 6t to the power 2 minus 2 is equal to 4. And we're going to solve for t. So obviously plus 2, we have 6t to the power 2 is equal to 6, divided by 6, divided by 6. T squared is equal to 1. And then if you square root, you'd have t is equal to plus or minus 1, because the square root of 1 is 1. But because we said t is greater than 0, we actually don't care about the negative version of 1 here. So it's just going to be t is equal to positive 1. So we're looking at our time at 1. So what do we do with this? Well, we're trying to find the acceleration. So let's use our acceleration part here. Because we know a of t was equal to 12t, we're going to plug in our time of 1. So it's going to be a of 1, which would just be 12 times 1, which is equal to 12. So we would get our acceleration, which would be 12, when the velocity is 4 meters a second. And that's it.